It begins with silence, not the ordinary kind. This is engineered silence, the deliberate, signed-off, paperwork-stamped silence of a machine NASA had formally stopped listening to. Somewhere beyond the orbit of the moon, a spacecraft the size of a large drum tumbles slowly against total black, its solar panels catching starlight it has no one left to report to. It has not spoken to Earth in years. Officially, it never will again. Then, on the night of May 29, 2014, in a converted McDonald's building near NASA's Ames Research Center in Mountain View, California, 4 engineers sit hunched over borrowed equipment, homemade software, and a rented radio dish 800 miles away in Puerto Rico. They are listening for a heartbeat nobody expects to find. At 9:26 p.m. Eastern, it answers. This is the real story of IC-3, the spacecraft NASA left for dead, and the outsiders who refused to let it stay that way. The signal that came back that night was faint. A single, narrow carrier tone, locked by the 1,000-foot dish at the Arecibo Observatory, then confirmed 20 minutes later by a smaller antenna at Morehead State University in Kentucky. It carried no data, just a frequency, steady and unmistakable, arriving from a spacecraft that NASA's own paperwork listed as unreachable. The team receiving it were not NASA employees. They were a self-funded group calling themselves the ISE-3 Reboot Project, led by former NASA engineer Dennis Wingo and space journalist Keith Cowing. They had spent months negotiating something that had never been done before, a legal agreement letting private citizens take operational control of a NASA spacecraft still technically owned by the United States government. 36 years. That's how long the spacecraft had existed by then, drifting through cislunar and heliocentric space, most of that time with no working transmitter on Earth capable of speaking its language. 12 of its 13 scientific instruments were still functioning. 0 personnel at NASA had planned on ever hearing from it again. To understand why a piece of 1970s hardware was still alive out there, and why anyone thought it was worth the trouble to find out, you have to go back to the beginning. On August 12, 1978, NASA launched a spacecraft called IC-3, the third of 3 international Sun-Earth Explorer satellites, a joint mission with the European Space Agency. Its job was to sit at a gravitational balance point 900,000 miles from Earth, called the L1 Lagrange point, and watch the solar wind before it ever reached us. No spacecraft had ever been stationed there before. IC-3 was first. For 4 years, it did exactly that. Then, in 1982, a NASA mission planner named Robert Farquhar looked at the aging probe and saw something nobody else did, a chance to redirect it, using a sequence of lunar gravity assists so intricate that some of his colleagues doubted it was possible. Farquhar's plan would use the moon's gravity 5 separate times to fling IC-3 out of Earth orbit entirely and send it toward a comet. The maneuver worked. Renamed the International Cometary Explorer, IC, the spacecraft was now headed somewhere no human-made object had ever gone. On September 11, 1985, ICE flew directly through the tail of Comet Giacobini-Zinner, roughly 4,400 miles from the comet's nucleus. It was the first spacecraft in history to make direct contact with a comet. The following year, while the world's attention turned to Halley's Comet and the European Space Agency's Giotto probe raced toward it, IC quietly gathered its own solar wind data from a distance, adding context to one of the most watched scientific events of the decade. Then the spacecraft simply kept working. Through the late 1980s and into the 1990s, it continued monitoring the solar wind, functioning as an early warning system for coronal mass ejections heading toward Earth. It had already outlived its planned mission by more than a decade. In 1997, NASA formally ended ICE's mission. The spacecraft was placed into a stable spin, its trajectory left to carry it on a long solar orbit that mission planners calculated would bring it back near Earth in August of 2014. Before shutting the book on it, NASA left themselves one instruction, buried in the mission archive: check on it when it comes back. In 2008, engineers briefly re-established contact to confirm the spacecraft was still functioning. It was. Then contact ended again, and the file closed for another 6 years. By the time 2014 arrived, though, the world that had built ISE-3 no longer existed. The specific radio transmitter hardware needed to talk to a 1970s-era NASA deep space probe had been decommissioned and scrapped years earlier. The radio frequencies once reserved for it had been reassigned to other missions. NASA had the will to check on its returning spacecraft. It no longer had the equipment. That gap is where Dennis Wingo and Keith Cowing stepped in. Wingo had spent decades working around old spacecraft hardware, and he'd become convinced that ISE-3's return in 2014 was a use-it-or-lose-it opportunity. Cowing had spent years covering NASA as a journalist and had the contacts to get a serious proposal in front of the right people. Together they built a plan: raise the money, build software to emulate NASA's obsolete communication protocol, borrow a modern radio telescope, and ask NASA for legal permission to try. NASA said yes. In April 2014, the team launched a crowdfunding campaign, and it raised more than its goal within days, proof that the public wanted this old machine to speak again as much as the engineers did. NASA signed what's known as a Space Act agreement, granting the citizen team something that had never been granted before: operational authority over an active NASA spacecraft without NASA itself running the mission. They rented time on Arecibo. They rented time at Morehead State. They wrote software from scratch to replicate a command language nobody had used in a generation. And on May 29, 2014, it worked. The carrier signal came back. Over the following days, the team achieved something even more remarkable: a full telemetry lock, meaning the spacecraft wasn't just answering, it was reporting its own condition back to Earth. Most of its instruments were healthy. Its power systems, batteries, and internal clock were functioning within expected ranges after 36 years in space. On July 2, 2014, the team did something nobody had attempted in over 25 years. They fired IC-3's thrusters. The burn was successful. For a moment, it looked like the impossible plan, nudging a decades-old spacecraft back into a useful orbit near Earth, might actually happen. Then they found the problem. The nitrogen gas used to pressurize the spacecraft's propellant tanks had slowly leaked away over 36 years in the vacuum of space. Without that pressure, there wasn't enough force behind the fuel to complete the larger trajectory correction the team needed. The engine could fire. It could not fire enough. IC-3 passed relatively close to the Moon and Earth in August 2014, exactly as Robert Farker's decades-old calculations had predicted it would. Then it continued on, back out into a long solar orbit, carrying it away from Earth and toward a return that mission planners estimate will happen around the year 2091. Contact faded again that autumn as the spacecraft's antenna geometry and available power worked against the team. The signal that had defied 36 years of silence went quiet once more, not because the spacecraft died, but because, once again, nobody on Earth had the means to keep listening. For Dennis Wingo, the IC-3 recovery was never really about one spacecraft. It was proof of something bigger, and he has said as much in interviews since. His theory, still debated in engineering circles, is this: NASA's archive of dead missions may not be nearly as dead as the paperwork suggests. Hardware built for the harsh radiation and thermal extremes of deep space is often extraordinarily durable. The very qualities that make it expensive to build also make it resistant to the kind of failure that ends a mission early. What actually kills most of these spacecraft, Wingo argues, isn't hardware failure at all. It's institutional abandonment, decommissioned ground stations, reassigned frequencies, retired staff, and budgets that move on to the next launch. If that's true, the graveyard of lost NASA missions might contain more survivors than anyone has bothered to check. It's a compelling idea. It's also one that mainstream mission engineers are quick to put guardrails around. NASA's own statements following the IC-3 reboot project were careful to draw a distinction between a spacecraft answering a signal and a spacecraft being fully operational. The nitrogen leak that doomed the 2014 course correction is exactly the kind of quiet, undramatic failure that engineers say is common in aging hardware, the kind that doesn't show up until the moment you actually need full performance. A transmitter that still works is not the same as a mission that can still be flown. There's also the matter of scale. Reviving IC-3 required a rare alignment of circumstances: a spacecraft on a predictable, decades-long return trajectory, enough surviving documentation to reconstruct its command protocols, and a narrow window in which the returning signal was even geometrically reachable from Earth. Most decommissioned spacecraft don't loop back for a second chance. Most never had documentation this complete to begin with. Engineers who worked on the reboot have been candid that IC-3 was, in many ways, a best-case scenario, not a template that can simply be repeated on demand. Even so, the core question Wingo raised hasn't gone away, and it's one that's only grown louder as more early-era spacecraft quietly complete unexpected orbits and drift back toward Earth's neighborhood. How many other machines are still out there? Still spinning, still charging their solar panels every time sunlight crosses them, still, in some technical sense, alive, waiting on a frequency nobody has listened to in decades, for a signal nobody thought to send. NASA's official archives list dozens of missions as concluded. Concluded isn't the same as gone. Somewhere in that list may be another IC-3, a piece of 1970s or 1980s engineering, built to a standard of durability modern budgets rarely allow, tumbling in silence simply because the people who once spoke to it moved on to other work. The 2014 reboot proved, for one spacecraft, that the silence wasn't permanent. It was a choice, and one that could, in theory, be unmade again. If it happened once by a handful of engineers working out of a decommissioned fast food restaurant with a rented radio dish and a crowdfunding page, the real mystery isn't whether it could happen again. It's how many more signals are already out there waiting for someone to build the receiver. If you want to know which spacecraft NASA is quietly still tracking today and which ones the agency has genuinely permanently lost, that's a story for next time.